All right. Good morning. Good morning. Good morning. Hope everyone's doing all right. Everyone's well. We had a great weekend. So we only have three sections left as far as new material is concerned. So that's a good thing. We'll be done with that. And then from there, we'll just be trying to knock out the rest of these tests, right? Let's see. 161. Trying to find another set of notes that we can lean on. Okay. Did anybody have any questions before we get started? Is everybody okay? Straight. All right. Let me go back to your notes for a second before we go there. So we're looking at 18.1 today, and it is titled Quadratic Equation by. All right, so 18.1 is quadratic equations by completing the square. And this is a note to myself, so you wouldn't copy what's in red. 61. All right. Everybody got the title before I switch sheets? Quadratic equation by completing square. All right. So we're going to start off talking about the square root property before we actually get all the way into completing the square. All right. So it says if u squared is equal to d, and I want to solve for u, I take the square root of both sides in order to, cancel out this square that's being applied to u. And then once that happens, I have to do plus or minus square root of the other side. So that's the square root property. Whenever you take the square root of both sides in order to solve, you have to use plus or minus on the other side that the square root doesn't cancel, or the other side that you weren't solving for. All right, so why does that happen? Well, first of all, let's look at using that. So if I had x squared equal to 25, and I wanted to solve, once again, I want to solve for x, I would take the square root of both sides. Square and square root cancel on the left. And then on the right, I have to do plus or minus square root of 25. All right. So why is that the case? Remember, whenever you're solving, you want all of the answers that make that statement true. Well, right here, I've written it, when I multiply, well, let's say this, when I take the square root of 25, I'm saying what two numbers multiplied to itself will give me 25. And so 5 times 5 will give me 25, but also -5 times -5 will give me 25. So that's what I was emphasizing here. So that's why you use plus or minus on both whenever you take the square root of both sides. Positive 5 times positive 5 will give me 25, but also negative 5 times negative 5 will give me 25. So that's why my answer will be plus or and minus or plus or minus 5 as my two solutions. And don't forget, we talked about whenever we're dealing with these quadratic situations, my highest power on my exponent is 2. So that means I should get my two solutions. And this is how we get them using the square root property. Once again, whenever you take the square root of both sides, from this point forward, no matter what class you're dealing with, whenever you take the square root of both sides, plus or minus has to be involved as a part of your solution set. All right. Any questions before we do another one? All right. So here, our original equation is 9x squared plus 25 equal to 0. So what we want to do is isolate this x squared just like we have here. So I would subtract 25 from both sides. Then divide by 9. Subtracting 25 from both sides gives me 9x squared equal to negative 25. And like I said, divide by 9. And that puts me here. All right, any questions on that part? So now that I have x squared isolated by itself, I can take the square root of both sides, which gives me plus or minus on the right, square root of negative 25 over 9. And then the square and the square root cancels on the left, which is what I need. Taking the square root of both sides, notice I have a negative under my radical. So the square root of negative 25 would be 5i, and then the square root of 9 is 3. All right, questions. Here I have x minus 2 squared equal to 6. So what's being squared is already isolated. I have a quantity that's being squared here. So you take the square root of both sides. Square and square root cancels. Leave me with just x minus 2. Then on the right, plus or minus square root of 6. Now I can finish solving for x by adding 2 to both sides. Yep. And that'll be plus or minus square root of 6. Normally this plus 2 you put in front of the plus or minus sign. So we have 2 plus or minus square root of 6. Now I forgot whether I need to check again, and I'll probably look before we leave, whether plus or minus is an option or not in my math lab. At one point it wasn't, but they may have it so that you can write it like this, 2 plus or minus square root of 6. But if not, then that just means you have to write it this way, 2 plus square root of 6, 2 minus square root of 6. Both that plus or minus represent 2 different numbers. So 2 plus square root of 6, comma 2 minus square root of 6. All right, questions. All right. Next one. Trying to erase this stuff. All right. So we have a very similar situation to the last one. We have x plus 4 squared equal to 81. So you want to get the square off of x plus 4. So we're going to take the square root of both sides. That'll give you x plus 4 equal to plus or minus square root of 81. Square root of 81 is 9, but then we can also subtract 4 from both sides. And that's x equal to -4 plus or minus 9. Now in the last one, we had 2 plus or minus square root of 6. I could not add the 2 or subtract the 2 from square root of 6 evenly, but here I can, so they do expect you to continue on and finish off the problem. So you can add 4 to 9 and subtract 4 from 9. So -4 plus 9, -4 minus 9 will give you 5 and 13, -13. So when you can go further, they are expecting you to do so. And don't just leave it as plus or minus, whatever. All right, any questions? All right, so any problems with completing square, not completing square root property before we look at completing square? All right. So in the completing square, we had to do square root property first because within the steps of completing square, the square root property lies. So completing the square, we have what, 6 steps? Yep, 6 steps. So to solve ax squared plus bx plus c equals 0, if a is not equal to 1, then divide both sides by a. In other words, divide each term by a. You want to isolate your c term to one side of the equation. Your c term, the term that's considered c, is your constant, the term that does not have anything to do with a variable. So here, just an idea of what we're talking about, that term should be taken over to the other side of your equation, that c term. Then we're going to take half of b and square it at the result of both sides of the equation. Step 4, we're going to factor the perfect square trinomial and then simplify the other side of the equation. Anybody still holding on to step 1? All right. Then we'll solve using the square root property, and then step 6 is always to check if you desire to do so. I'll give you a chance to finish writing those down. All right, can we try it out? All right, so let's look at the first one. We're going to try to go step by step to make sure we're good as far as the completing the square process is concerned. So here we have x squared minus 6x plus 4 equals 0. So the first step says if a is not equal to 1. So in other words, if a is equal to 1, a is the number that's sitting in front of x squared. That's your coefficient of x squared. If a is not equal to 1, then you do step 1. But if it is equal to 1, there's nothing to do. So going back here, notice a is equal to 1. So there's nothing for us to do as far as step 1 is concerned. All right. Step 2, we want to isolate the constant. So we subtract 4 from both sides. We want to get that 4 to the other side of the equation. So we subtract 4 from both sides, giving us x squared minus 6x equal to -4. right. So step 3, we're going to take half of b. B is -6. That's what's sitting in front of your x. So we're going to take half of -6 and then square it. So half of -6 is -3. Squaring that is 9. And then add that 9 to both sides of your equation. We're in step 3. So notice now we have x squared minus 6x plus 9 equal to -4 plus 9. So most definitely don't forget that whatever you do to one side of your equation, you have to do to the other in order to keep your equivalency. So that's why you have to add 9 to both sides of your equation. All right. Any problems with step 3 or any problems up to step 3? All right. So on the right side, we can simplify that easily. -4 plus 9 is 5. Then we factor this trinomial. And if you ever have any problems with your factoring, that's why I was emphasizing here with this arrow. Whatever half your b term is, that is what's going to go right here with your x inside of your square. So half of -6 was -3. So that's why we have x minus 3 squared. And then, of course, on the other side is equal to 5, which is what we did first. So whatever half your b term is will always go in there with x. Any questions? So now we can solve using the square root property to get that square off of x minus 3. Take the square of both sides, square root of both sides, excuse me. That'll cancel out the square here, leaving you with just x minus 3. And on the right, we just have the square root of 5. But because of the square root property, whenever you take the square root of both sides, plus or minus square root of 5. And that's going to be 3 plus or minus square root of 5 after you add 3 to both sides of the equation. All right, questions before we do it again? All right. Let's look at the next one. 9x squared minus 6x minus 4 equal to 0. This time, a is not equal to 1. It's equal to 9. So we need to divide each term by 9. So 9x squared over 9 minus 6x over 9 minus 4 over 9 equals 0 over 9. 9 over 9 cancels, which is what we need. That's why we have. That's why we do this, so we can have 1 in front of x squared. -6 over 9 reduced to 2 over 3. 4 over 9 still 4 over 9, and then 0 over 9, which is 0. Step 2, isolate the constant. So we'll add 4 over 9 to both sides of the equation. And that's x squared minus 2/3 x equal to 4 over 9. All right. Now, third step, you need to take half of your b term. So half of -2/3, remember this is multiplying whatever by 1/2. So in this case, it's -2/3. So 1/2 times -2/3 will reduce down to -1/3. And then squaring that will be 1/9. And you'll add that 1/9 to both sides of your equation. All right. So just like before, we need to simplify the right, factor to the left. So once again, if you're factoring, if you're unsure about your factoring, when it comes to this trinomial right here, whatever half of your b term was is what should go into your parentheses. And that's what I did right here. Half of -2/3 was -1/3. So that's why we have x minus 1/3 squared. And then here 4/9 plus 1/9 is 5/9. Any questions before we get into step 5? All right, take the square root of both sides. Square and square root cancels on the left, leaving you with x minus 1/3. On the right, plus or minus square root of 5/9. Here is the reducing of that. Take the square root of each top and bottom individually. Square root of 5 is just the square root of 5, but the square root of 9 is 3. So then we have x minus 1/3 equal to plus or minus square root of 5/3. Add 1/3 to both sides. And this will be my result, 1/3 plus or minus square root of 5/3. Or since you have the same denominator, you can put them together. Neither one of them are imaginary. So you just bring them together. Any questions?
Mr. Tucker,
Mm-hmm.
the math lab, which answer would it take? The
Either
first
or.
answer?
Either or is fine. Mm-hmm.
Yep. Okay.
Yep.
Thank you.
No problem. Thank you for asking. Yep. Take either one. Okay. I will say this, if it's imaginary, they expect now, let's say if I had 1/3 plus or minus I square root of 5. If it's imaginary, you have that I, that complex number, they are expecting it to be separate. So we talked about that last class about your real part and imaginary part. But since neither one of them are imaginary, it's okay to, bring them together like this or, write it that way. All right. All right, let's see, what's the other technique? Quadratic formula, okay. 18.2. So this is 18.2 for you guys. Quadratic formula. All right, hold on one second. Let me write a note to myself. All right, so your quadratic formula, x equal to -b plus or minus b squared, the square root of b squared minus 4ac all over 2a. Wherein just like before, we get an a, b, and c from your generic or your general, I think that's standard form, your standard form of your quadratic equation, ax squared plus bx plus c equal to 0. And notice that one side has to be equal to 0 before you identify your a, b, and c. All right. So our first one, 8x squared plus 2x equal to 1. And I should have. So that's our original equation. And we want to solve for x using the quadratic formula. First thing we need to do is to set one side equal to 0. And we can subtract 1 from both sides. All right. Once you subtracted 1 from both sides, set one side equal to 0. Now you can pick out what A, B, and C are. What's in front of x squared is your A. What's in front of x is B. And then the lone constant is C. And then from there, you plug it into the equation. So there's a minus sign in front of B in your formula. So make sure you don't lose that. So you're plugging in +2. So that's -2 square root of plus or minus square root of 2 squared minus 4 times 8 times -1 over 2 times 8. So you put in 2 where you see B, 8 where you see A, and then that -1 where you see C. So from there, you will reduce. You have -2 plus or minus 2 squared is 4. Then -4 times 8 is -32 times -1, which is +32. That's how we got that. Two times 8 at the bottom is 16. So now 4 plus 32 is 36. Square root of 36 is 6. And once again, we have all real numbers here. Oh, my eraser still on. Have all real numbers here. So you are expected to continue with that reducing. The 2 and the 6 can be added together, so you're expected to do so. So it's -2 plus 6 over 16, -2 minus 6 over 16. Gives you 4 over 16, which will reduce down to 1/4. Then -8 over 16, which will leave you with -1 over 2. Any questions? All right. Try another one. Next one, 3x squared minus 2x plus 4 equal to 0. In this case, we already have our equation set equal to 0. So we don't have to do anything extra in order to make that happen. We can go ahead and identify A, B, and C. What's in front of x squared is 3, so that's A. What's in front of x is -2, so that's B. And then the term or number that is not associated with a variable is going to be C, which is 4 for us. All right, plug it into the formula. So make sure you don't lose a negative. We have -2 as B, and there's a minus sign in the formula, so that's why we have -2. So just make sure you don't lose your negatives when you go about using the formula. A lot of people make that mistake, so be careful. And then that's -2 squared minus 4 times 3 times 4 under the radical, and that's all over 2 times 3. Any questions? All right. So simplify negative to negative turns positive. So now it's positive 2 on the inside, negative inside of the radical, negative 2 squared is positive 4. Here, negative 4 times 3 is negative 12 times 4, which is negative 48. 4 minus 48, square root of negative 44. Then in the green, you see I have the breakdown of the square root of negative 44. So we take the square root of what we can take the square root of, leave what's in the radical that's left over. So break it up into negative 4 times 11. Take the square root of negative 4, which is 2i, and leave the 11 under the radical. So that goes to here. So now we have 2 plus or minus 2i square root of 11 over 6. Any problems? Any problems? All right. So we do have a real part and imaginary part, so we need to break it up, take the 6 into each piece. And that'll be 1/3 plus or minus I square root of 11 over 3. That's our final answer. Any questions? Any questions? All right. Let's see, it should be, see if they have any other type of combinations that we should be looking for. All right, so any questions on anything before we go any further? How come I don't see? I click on the wrong thing. Trying to see some guys, because see my math lab did a little bit of an update.
Miss Tucker,
Yes.
isn't the I should be separated?
Let me get there. No, this is fine. Oh, my eraser's still on. There we go. So no, this is fine. When I say separate, now you can write it multiple ways, but what I was saying separated, this and this need to be separated, and you can't write this like, can't write it like this. Hold on. So this is together, but when you have your imaginary and your real part, they want them as 2 different fractions. Separated into 2 different fractions. So that's what I mean by your real part should be separated from your imaginary part. They do not want you to write it this way.
Okay, so it's not the radical 11 over 3i.
Now, and that's what I meant when I said there's multiple ways of writing it. So I think that's what you were referencing, right?
Correct.
Yeah, you can write it like that as well. That is fine.
Okay, thank you.
Yeah, not a problem. All right, so that is the quadratic formula. Let's see, did they talk about the discriminants? Yeah, quadratic formula. to solve. Do one more like this. I think that's a good one. See anything else? Let me see. All right, so all right, what's going on with my notes? How do I get way down there? Okay. Show you one more, and then we should be good to go. All right, so here we have 1/5 x squared, y squared, minus negative y minus 1/20th. Oh, minus 1/20th or 1/20. So here we have fractions. But we don't have to use these fractions. What we can do is what we've done in the past when we say clear out your fractions. So just like before, multiply by the LCD. And your LCD is 20. Talking about least common denominator between the 5 and 20. All right. So 5 goes into 20, leaves you with 4. 20 cancels out completely, leaves you with just 1. And now we have 4y squared equal to negative 20y minus 1. All right, any problems? So now we need to set one side equal to 0. Remember, before we establish what A, B, and C are, one side has to be equal to 0. I like my leading coefficient to be positive. That's just my preference. It doesn't matter if it's negative or positive or not. Once you plug everything into your quadratic formula correctly, it will all, even out and still give you the same answer. But like I said, I like to have my leading coefficient positive. So I'm going to add 20y and 1 to both sides of the equation. So that they cancel on the right. Now I have 4y squared plus 20y plus 1 equal to 0. Any questions before we go on to the next step? All right, now that you have one side equal to 0, A is equal to 4, B is equal to 20, C is equal to 1. Going back to our formula, quadratic formula. Negative b plus or minus square root of b squared minus 4ac all over 2a. And now we plug in everything accordingly. All right. So it's negative 20 plus or minus square root of 20 squared minus 4 times 4 times 1 over 2 times 4. So we're looking at, let's see, I'll break that down. So that's 384. Okay. So I can break up that 384 into 64 times 6. Make sure. Yep. All right. Take the square root of 64. Leave the 6 under the radical. So I'm looking at negative 20 plus or minus 8 square root of 6 over 8. And then to simplify it all the way down, take the 8 into each. All right, 8's cancel here. Here, 4 goes into each. Leaves you with 5 and 2. So our final answer is negative 5 over 2 plus or minus square root of 6. And that's good enough. All right, questions. All right. Everybody good? Everybody straight on those two methods, completing the square and quadratic formula. Anybody have any questions on anything else? Any other assignments? Any other problems from previous sections? Okay. So our last section is doing graphing the quadratic functions. So we can hold off and do that next class. It's only one section. So once again, that'll leave room for you guys to ask whatever questions you want to ask. So make sure you're trying this stuff out. See if you have any issues with anything. Make sure we're good to go when it comes to closing out this week. I'll offer another testing opportunity on Friday. And then also next week, you know, each class period will be a testing opportunity. If we get done with 18, what is 18.6, I believe? Yeah, it goes 18.1, 18.2, and then 18.6. If we get done with 18.6, you know, let's say if it don't take at the most half an hour, I don't mind opening up the floor for someone taking the test on next class as well. So if that's what you want to do, just be prepared to do so as far as enabling cameras, you know, and all the good stuff like that. So just throwing it out there. Any questions before we close today? Everybody good? All right. So once again, if you're ready to take a test on Thursday, like I said, 18.6 shouldn't take that long. Only thing that may slow us up is if we have questions, and you know that time is for that first. Then if we're done and no one have any questions, I'll look for a test. But also Friday will be a testing opportunity as well. So if you're gonna take tests with me, we know we have 3 solid days left. Friday and then next week of Monday and Wednesday. If you need more time than that, then you got to make sure you contact Mr. Davis and go from there. All right. So have a good one. Be safe, and I'll see you guys next class.
Thank you.
Thank you.